Alright folks, let me fix this setting. There we go. So, we are back to talking about central tendency, and today we're going to be talking about our second measure of central tendency, the median, to follow up on the mean that we discussed earlier. So, the median again is intended to sum up the data set in one number that describes the center or the middle of it as accurately as possible. Here's how we calculate the median. We take every score that we've got, we order them from lowest to highest, and we find the middle one, and that is the median. We got 5 scores here. We say, okay, we got 5 scores. The middle score is right in the middle, that third highest score. The median would be 8 in this case. So here's how the median differs from the mean. The median represents the average person, the person right in the middle of the distribution. What's their score? Or the data point if we're not measuring people. What's the score of the person smack in the middle where half of the scores are above them, half of the scores are below them? The person in the 50th percentile, say. The mean involves adding all the scores up and finding the average score. That means the scores that are farther away from average are more influential on the mean. They will make they will drag the mean towards them. They'll make it unusually high or unusually low. We'll see what that looks like in just a moment. But there's no special symbol for the median, and it divides the distribution exactly in half. We know half the people scored at or above this number, half the people scored at or below it. So here's how we find the median. There's no special written out formula, but all we do is line up the scores from lowest to highest. If a score is repeated in your data set, make sure that it shows up just as many times in the order as it does in the data set. Don't just write the score down once and be lumping together several people with that same score. And then we figure out how many scores there are to the middle score. The way that we do that, we take the total number, we might call our n, and we add 1 to it, divide it by 2. We'll see what that looks like in a moment. Then we identify that middle score. Now, if you have an odd number of scores, well, when you add 1 to an odd number, it becomes an even number. You can directly identify that middle score. If you have an even number of scores, though, you wind up with a fractional number. You wind up with something like find the 3.5 highest number. In that case, you take the number above and below that middle score, so the third and the fourth highest case in our example, you add them together, you divide by 2. You take the average of them. So let's see what that looks like. Here's a data set with 9 scores in it, an odd number of scores. We take 9, we add 1, that adds to 10. We divide by 2. We're looking for the 5th highest score, or the 5th lowest score. It's going to be the same thing. Either way, we count up 1, 2, 3, 4, 5, or we can count down 1, 2, 3, 4, 5. We wind up in the same place. We wind up finding that our median is 5. Half the people are at or below that number 5. Half the people are at or above that number 5. With even numbers, it's a little trickier. Here we have 8 scores, so we say, okay, 8 plus 1 is 9. 9 divided by 2 is 4.5. There is no 4.5 highest score, so instead we say we're going to take the 4th highest and the 5th highest score and average them together. 1, 2, 3, 4. 4th highest score is 6. 5th highest score is 9. We add them together, divide by 2. The median would be 7.5. So the median is very useful when a distribution is skewed or when we have what we call outliers. People are really far away from average. Those things will deviate the average score, the mean, but they won't affect the median nearly as much. Let's look at how this works. Let's say that we go around your campus or your hometown and you ask 20 people, you stop at random, how much cash do they have in their pocket? Most people give us pretty normal scores here, $20, $5, $30, $50. But one person not only has $10,000 cash money in their pocket, they're willing to tell a total stranger about that. Seems like not the smartest move. Anyway, they're really, really far away from every single other score. Here's what happens if you calculate the mean of that data set. You get $518.25. Remember, the purpose of central tendency is to describe the data set in one number in a way that reflects a typical or representative score. $518.25 doesn't represent anybody. It doesn't represent the 19 people who are far below that number, and it doesn't represent the one person who's even farther above it. It's not a good measure of central tendency in this case. It's been distorted by our outlier, our person with a lot of money in their pocket. But the median, again, is just $20. When we order the scores from lowest to highest, and you can do this yourself and count up to the 10.5 highest score, you'll find $20. That's a much better measure of central tendency. Half the people in our sample have $20 or less in the pocket, half the people have $20 or more. It's a much better number for the purposes of what central tendency is trying to do. The mode, which we're going to talk about in the next piece, is $5. It's just the most frequent score. If you've kind of powered through this this little lecture, I recommend moving on to that one. It's going to be a nice short one. Not much to say about the mode. See you there.